So in this problem there are a group of cells. So 300 cells, each having an internal resistance 0.3 ohm, is loaded with an external resistance. Capital R is 10 ohm. Find the number n of parallel groups. So there will be small n number of uh, these rows, right? There will be small n number of rows, each row containing several of these cells, right? How many cells, that we also can find out. Okay, so it's like this only, and there is the external resistance R. Now, so let there be n rows, and each row has m cells. So obviously m into n is equal to 300. So each row has m cells. So suppose the internal resistance is smaller. So for each row the resistance is, so each row you can approximate to be a battery, but you can combine the battery. So each battery having EMF E. So M times E, and the internal resistance is sum of M times R. So such there will be n such rows, and then the external resistance R. So such n rows. So again you can combine. So n rows. So what is the equivalent resistance actually? So equivalent resistance is as if they are in parallel connection. So MR by N, and the battery will also have the same EMF ME, though that does not matter. Only you know that from maximum power transfer theorem we have to do this this R is equal to small m into R by capital N for maximum power. For maximum power in the external resistance R, capital R. So you have to find n. So substitute, so m into n is equal to 300, right? So m is equal to 300 by n. So I can write capital R is equal to small r into 300 by n square. So now you put the value of capital R, or say this n square is equal to 300 into small r divided by capital R. So that is 300 into small r is 0.3 divided by capital R is 10. So you have here, so that's 300 into 3 by 100. So you know n is equal to 3. So there will be 3 rows.